Hey everybody, it's Mr. N here, and we are going to do the 9-7 lesson today, and this is on the law of sines, and we're going to cover the law of cosines as well. So hold on tight, this one's a bit tough. Before we begin though, I would like you to scroll down to the end of the notes for the warm-ups for PM 47. I want you to complete this. I will be calling on you tomorrow. Actually, Emily and Bryn will be calling on you. So be ready to have these answers, and we will post these up. This is a good summary of what we did in this chapter, and you can expect this on some sort of assessment. Haven't figured out how we're going to do that yet, but expect stuff like this to be on there. So let's scroll all the way back up to the top and get started with our notes here. Okay, so first thing we're going to talk about is the area of a triangle. So for the area of a triangle, what you have been taught in the past is that suppose you had some sort of triangle. Let me put the pen mark. And we've got some sort of triangle here. We know that the area is 1/2 times the base times the height, where that is the base right along here, and this is the height. So what you needed to know to be able to solve this is you had to have the height. You had to have this height, and you had to have a base. But suppose you didn't have any of that. Well, we can solve this through sine. So if I take a look at this, and I'm going to take my triangle again, and this is angle A right in here, I can solve for this height by using the sine, because the sine of A is this opposite over the hypotenuse, because that would be the right triangle in here if I took that out. And suppose I called this, just like they did in this little triangle, C. So this would be H over C. Now, suppose I wanted to go ahead and solve for the height. Cross multiply, I would get C times the sine of A equals the height. So I would put this in my formula right there. So A equals 1/2 times the base times C sine A. So you can use that instead to solve for the area of a triangle without knowing the height. So right here, 1/2 BC sine A. You can also, suppose you had a different side and you wanted to work with angle C, you could do the same thing. That would be AB. Or if you wanted to work with angle B, you would just have to draw the altitude this way, and that would work as well. So we have 3 different formulas here, but I want you to pay attention to what is special about these 3 formulas. So I want to just go ahead and erase something here. I want to erase this. And here's what I want you to pay attention to. Take a look. We've got the area. Let's use a different pointer. I know some of you like this lightsaber. We'll just go ahead and do the lightsaber. So you have the area equals 1/2 BC sine A. But take a look. It's these 2 sides and the included angle. Look at where B is. Look at where C is. So it's the 2 sides with the included angle. BC sine A. So you could do the other one. AC, look, here's A, and there's C, and I'm using the sine of B. And finally, you could do the other one, which is A, B, and then the angle would be C. So it just depends on which angle you're talking about. So if I'm talking about some angle right here, I would use these 2 sides with that angle. So the sine of that angle, suppose I call this X and Y, and this angle W, it would be 1/2 XY times the sine of that W. So whatever you use, it's got to be the included angle between those 2 sides. So a recap, we just learned how to find the area of a triangle, of any triangle, without having to find the height. So it was all in this formula, in one of these formulas that we used, and we don't need to know the height anymore as long as we know the 3 sides. So that's part one of this lesson. There's so many different parts of this lesson. That's probably one of the easier ones. So let's move on to the next thing. So what we've been doing with the triangles is we've used SOHCAHTOA, we've used the Pythagorean Theorem, so we've been able to find sides and angles. So when we had the Pythagorean Theorem, we had a triangle, and it was a right triangle, and we will call this A, B, C, so I will call this little a, little b, little c, like that. And as long as it was a right triangle, the Pythagorean theorem said I can relate the three sides, A, B, and C. So that's what the Pythagorean theorem told me. I can relate A, B, and C. But then we said, well, how are we going to relate the angles? Well, then we did special right triangles. If it was 45, 45, 90, or 60, 30, 90, I could be able to find the sides. Then we said, well, what if it wasn't those angles? How can I find angle A, angle B? Then we said SOHCAHTOA. So we added SOHCAHTOA into the mix, and we said SOHCAHTOA, and this will work, but the condition here is the triangle had to be a right triangle. If it was not a right triangle, SOHCAHTOA cannot work. So what do? That's the next question. If we don't have a right triangle, so the triangle had to be a right triangle, but what if it didn't? What if it wasn't a right triangle? Look at this example. Here it is. Triangle A, B, C, and I call this little a, little b, and little c for the sides. This is not a right triangle. I have to be able to relate the side lengths and the angles to any triangle. So that was the next step. How can we advance this further so that we can use these for any triangle? So let's move this up a little bit. And the first one is called the Law of Sines. So this Law of Sines allows me to be able to relate these sides and these angles even if it's not a right triangle. Now, you don't want to, this will work for right triangles as well, but you don't want to use it if you have a right triangle because the other methods are easier. This is starting to get complex. So, if we have triangle ABC, this triangle right here, here's a ratio I could set up. I could say the sine of A over little a equals the sine of B over little b equals the sine of C over little c. Right here, sine A over little a, sine B over... You could do it the other way around, A over sine A, B over sine B, C. It doesn't matter. It's the same thing because we're setting them up as ratios. This allows you to find the angles and the sides, but there's a catch to it. So for the law of sines to work, you need to have a situation where you have angle, angle, side, angle, or side, side, angle. Wait, what does that mean? Angle, angle, side means I need two angles and one of the sides. Notice, if I don't have two angles and one of the sides, if I have just the three angles, I can't solve for those because the ratio doesn't work. Suppose I had angle, side, angle. Angle, side, angle. Okay, if I had that situation, I could set up a ratio because then I can solve for the third angle. Side, side, angle. Two sides and one of the angles. Side, side, and an angle. I can solve this ratio. So basically what this is saying, and here's how you know. You don't have to memorize angle, angle. You don't have to memorize this stuff. Just set up the ratio. If it works and you can solve for a variable, then you're set. You're good to go. If it doesn't, then you have to do something else. If it doesn't work, then you have to use the law of cosines. And I'll do the examples and show you when it works, when it doesn't. There's also something else called the ambiguous case right here that I want you to be aware of. We are not going to do this in this class. You'll probably cover in Algebra 2, most likely. Sometimes they don't even talk about it so much anymore in Algebra 2. It might push over to pre-calc. But the ambiguous case where you can have no triangle, one triangle, or two triangles. Now, I'm not going to get into this because you don't have to worry about it in my class. So we're just going to focus on the law of sines that works, and if it doesn't work, we're going to do the law of cosines. So let's see where the law of sines fails so I can teach you the law of cosines real fast, and then we'll do a bunch of examples. So over here, suppose I had three sides and no angles. So if I had A, B, and C, but none of these angles, I can't set up the ratio to solve for any of the angles. Do you see how that would work? There's no way I could do that. So law of sines would fail. So since the law of sines fails in that case, or if I had the three angles, I couldn't do that. When the law of sine fails, you need to use the law of cosines. You always set it up with the law of sines first when it's not a right triangle. So step one, let me write all these down so you can remember. Step one, if it's a right triangle, then you use Pythagorean Theorem, special right triangles, which are the 45, 45, 90, 60, 30, 90, or you use SOHCAHTOA. If it's not a right triangle, you first do the law of sines. If that doesn't work, then you try the law of cosines. Do not do the law of cosines right away. Save that to the very end, because the law of cosines is kind of a little bit more complex than the other ones. The law of sines is actually not that bad when you start using it, because you'll see that it's just a ratio. So let's take a look at the law of cosines. What does the law of cosine tell us? Here's what the law of cosines says. Now, often I will cover something so that you guys can see it a little bit better here. So let me go ahead and do that, and we're going to do this. Draw the shape in here, and I'm going to cover this just temporarily so you guys can see this. So for the law of cosines, here it is. It says a squared equals b squared plus c squared. What does this part remind you of? Yep, Pythagorean theorem. A squared equals b squared plus c squared. Normally you see it as c squared equals a squared plus b squared. That's fine, but that reminds you of the Pythagorean theorem. But here's the twist. Here's the part where it's not a right triangle. So this is the Pythagorean theorem minus the part that's not a right triangle. That's kind of how you got to think of it. But more importantly, here's what I want you to pay attention to. Look at this triangle, A, B, C. That's little a, that's little b, and that's little c. I just named them so that the opposite side goes with the angle. Take a look at this. If I want to solve for little a, I would use the other two sides, b squared, c squared, minus, look at the pattern, minus 2 times bc times the cosine a. So I started with a, I finished with a. Little a, angle a, cosine of angle a. bc minus 2bc. So you can set it up for whatever side you're talking about. So now I can go ahead and move this, and I'll show you that. Look at the next one. If I'm talking about side B, I finish with cosine B. It's the other two sides here that get squared, minus 2 times these two sides. C squared. Finish with cosine C. Other two sides, minus 2AB. So that works out for you, and it doesn't matter which one you use, just depending on what you're trying to solve for. So that's part 3 of this lesson. So part 1 was finding the area of a triangle. Part 2 was the law of sines. Part 3 was the law of cosines. And one last thing. Because this kind of all goes together, it's a great time to show you this. And this is called Heron's formula. Sometimes they call it Hero's formula, but Heron was a pretty good mathematician. And it was back in the toga days when he figured this out. And to find the area of any triangle, so we started off finding the area of a triangle, and we're going to finish off with another formula to find the area of a triangle. This time, I don't need any angles. All I need to know is 3 sides of a triangle. It doesn't matter what the angles are, as long as I know the 3 sides of a triangle, and this is a super powerful formula, I can find the area. And the area is equal to the square root of S. Okay, what is S? S is the semi-perimeter. That means add up the 3 sides, divide by a half. Half the perimeter. Add up the 3 sides, divide by, so that's S. and we say s minus a, s minus b, s minus c, square root of all that. So this times this times this times this. Pretty interesting that he came up and found this out way back when. But it's a really cool, really powerful formula, and you can see that this gets used a lot in the real world because you don't necessarily have to measure the angles. As long as you know the length of the three sides, you can find the area of this triangle. So now we are going to do some examples. So you have your student journals with you at home, and I want you to turn to page 276, and we're going to do problems 1 through 8. So I am going to add a second here, and I'm going to add the file. So hold on while I do that. Okay, so I have this here now, and let's take a look and let's do some of these problems. Let's see how this works out. Okay, so it says for the first part, use your calculator to find the trigonometric ratio, round your answer to 4 decimal places. So for the first one, we have the sine of 225. I put this into my calculator, and I end up with negative 0.7071 for the cosine of 111, cosine 111, and the calculator, I end up with negative 0.3584. Again, I'm just putting these in my calculator. So the next one, the tangent of 96, comes out to be negative 9.5144. All right, find the area of a triangle. Round your answer to the nearest tenth. So what we need here is, suppose I had this angle, which I do. I need the two sides that make up that angle. That's the included angle between these two sides. So I can say the area is 1/2 these times these two sides times the 14 times the 9 times the sine of that angle that makes up those two sides. So on my calculator, I just work this out. I could just reduce that 7 right now and say it's 7 times 9 times the sine of 79. So that would be, I could just do it all at once. 7 times 9 times the sine of 79 on the calculator comes out to be an area of 61.8425. Okay, moving on to the next one. This is the angle right here. These are the two sides that make up the angle. So I know that the area is 1/2 times 22 times 19 times the sine of 24. So putting all this into our calculators, 0.5 times 22 times 19 times the sine of 24, all comes out to be 85.0079. So we're just going to say the area is approximately 85.0. All right, let's move on to these final 3, and then we're going to do some other examples that aren't on here, so I'm going to have you go back to your notes after this. Okay, it says in exercises 6 through 8, solve the triangle, round decimal answers to the nearest tenth. Okay, we talked about this before. Whenever they ask you to solve a triangle, that means we need to know all the angles, all the sides. So, for this triangle, the first thing to do is to solve for angle C on number 6, because that's the easiest. So 180 minus 50 minus 30, so that's 80. So that gives me angle C, which is going to be 100 degrees. Done. So what's left for me to find? Well, I just found angle C right here. So I still need to find side, we'll call that C, and side, we'll call that A. So we are going to call this one side C right here because it's opposite the big C, and I'll call this one side A. So that's what's left for me to find. Okay, this is not a right triangle. I cannot use SOHCAHTOA. I cannot use the Pythagorean Theorem. So I have to start with the Law of Sines. Okay, so right here, let's say again, don't go to the law of cosines unless you have to. In fact, on all of these, you should be able to do, oh, the last one you'll have to do the law of cosines. Okay, so let's start with the law of sines. Over here, I've got the sine of 30 over the opposite side, 22. I've got the sine of 50 over its opposite side, which is a, and I've got the sine of c, which I found to be 100 over its opposite side, little c. So I know the sine of c, that's 100. But take a look. Before I even go to that, I can use these two right here, and I could solve for that guy, little a. So let me break this ratio apart. I'm going to move this even further up here. Let's break this ratio apart, and we're going to say the sine of 30 over 22 equals the sine of 50 over a. So I use the law of sines here. Cross multiply, I'll get a times the sine of 30 equals 22 times the sine of 50. To solve for a, I can get rid of and just divide each side by the sine of 30. I don't need to use arc sine or inverse sine or any of that because I have an angle, it's 30. So divide that out. So a, and if that bothers you, then find the sine of 30. Find the sine of 50 on the other side. So in other words, the sine of 30 and the sine of 50, so sine of 30 would be 0.5. So I could say a times 0.5 equals 22. Sine of 50 would be 0.7660. If you wanted to do that, then solve for a. If that to you looks better, do it that way. So I have this right here, 22 times the sine of 50 over the sine of 30. And I'm going to just put this all in my calculator. So 22 sine times the sine of 50. Now take that answer and divide it by the sine of 30. And I will get a as being 33.706 if I round it in this case. 33.706. So now I found little a over here. The only thing left for me to do is find this little c. So let's go ahead and do that, and we'll set this up. Well, what do I need to set it up? I already have it. I've got this whole thing. I'm just going to rewrite this whole thing down here. I've got the sine of 30 over 22 equals the sine of 50 over a equals the sine of c, which I know is 100 because I solved for angle c over little c. In fact, I can even put the little a in there because I know what that is. So it doesn't matter which of these two ratios you set up. You're solving for this c. You could set up these two ratios, or you could set up these two right here. Let me highlight it. I could set up this one and this one right there. So we could do that. Let's just go ahead and do that one since I don't want to use that decimal for a. That's the only reason, no other reason. So I have the sine of 30 over 22 equals the sine of 100 over little c. Cross multiply. I will get c times the sine of 30 equals 22 times the sine of 100. I'm going to move this up again. Uh-oh. Oh, I hate it when the software does this. Can't move it up too much then, so we'll just continue on with what we got. So c will be 22 sine of 100 over the sine of 30, and that comes out to be, on our calculators, let's take a look, 43.3315. So now I have the whole triangle. All right, let's move on to the next problem. So I think we're going to have issues here with moving this, so I'm just going to slide it over this way and slide this stuff out of the way a little bit here, since it looks like it's going to give me a hard time. Okay, let me do this next problem. And here we have this triangle. It is not a right triangle, so I can't use SOHCAHTOA. I can't use any of the special right triangle ones, Pythagorean Theorem, none of that. I only have one angle in here. So let's start setting it up with the law of sines. So here's sine A over little a, sine B over little b, sine C over little c. Okay, here's angle A. So I have the sine of 82 over 25 equals the sine of B. I don't know what angle B is, over 16, so that's little b. And then sine of C, I don't know what angle C is, and I don't know what little side C is. So those are two variables I do not have. So I take a look at this and I say, all right, do I have enough info to be able to solve for something? Yes. Here is this ratio, the sine of 82 over 25, right here. Sine of 82 over 25, sine of B over 16. I could use this ratio. Notice if I use this one, I have too many variables. If I set these two equal, you only need two of these, whether it's the first two, the last two, or the first and the last. You only need to use two of these to set up that ratio. But the ratio shows you the three equivalent parts. This part, this part, this part. We only need two. Don't want to use the last two because I don't know these two values. Don't want to use the first and the last because, again, I don't know these two values. But if I use these two, I have a value here, value. All I need to do is solve for that b. So let's go ahead and do that. So we are going to say the sine of 82 over 25 equals the sine of b over 16. And that's what I'm going to solve for right here is this b. So 16, cross multiply, 16 times the sine of 82 over 25 equals the sine of b. I will let you see what I did there. All I did was cross multiply this one there. And you could cross multiply, but then you'd have to divide the 25 again. If at this point you don't like doing it that way, you can change this sine of 82. You can change that to a decimal. If it makes you see the problem better as a decimal, then change it to a decimal. All right, so now moving on. I'm going to put this in my calculators, and I will get 16 times the sine of 82 divided by 25. I will get 0.63377 equals the sine of b. To solve for the angle, I need the inverse sine of this. So, inverse sine of 0.63377, I will get an angle of, so that was what b is, I will get an angle of 39.3, we'll say 3289 degrees. So now I have angle B. I can quickly solve for angle C. Why? Because I know angle A, I know angle B, so angle C will be 180 minus 82 minus 39.3289. So 180 minus 82 minus that answer I had gotten gives me angle C as being 58.671. We'll leave it there, degrees. So now I have angle C. What's left for me to find? Well, I do not know what side C is. So take a look so far. I have found this one. I know what angle B is. I found this one. The only thing left for me to find is at angle C. So let's see. We can set this up. We could just use this ratio again. Oops. And this would be the sine of 82 over 25 equals the sine of C. I know what angle C is. I could have even done what angle, I could have done these two instead, but that's fine, doesn't matter. 58.671 over little c. So little c will be, if you cross multiply and solve, this goes here, this goes there, divide by the sine of 82, so you end up with 25 times the sine of 58.671 all over the sine of 82. I will pause, take a look at, make sure you see what I did there. So practice this cross multiplication, make sure you got it down, because some of you, that's where your questions are. Again, c times this, 25 times that. If it helps you to change these as a decimal right now, change them as a decimal, that's okay. So 25 times the sine of 58.671, and then divide that answer by the sine of 82, you will end up with 21.5647 for little c. All right, so let's take a look at this last problem. Let's see if I'm able to move any of this stuff out of the way. Again, this is kind of giving me a hard time here. I don't know why the software sometimes does this, but it does. Okay, so I made some room, and let's take a look at this last problem. So here we have this triangle right here, and on this triangle, we've got 3 sides and none of the angles. So let's see what we could do with 3 sides and none of the angles. So let me pick another color here. We'll go to the purple. Okay, it's not a right triangle. I can't use SOHCAHTOA, I can't use Pythagorean Theorem, I can't use special right triangles because it's not a right triangle. I always check for that first. Since I can't use those, I'm going to need to use the law of sines. So I set this up. I've got the sine of A over its opposite side, that'd be little a, which is 5. The sine of B, which is going to be over little b, the opposite side, 7, which is now equal to these 3 equivalent ratios, the sine of C over 3. And that's the opposite side from C. Okay, so if I take a look at these 2 ratios right here, I have 2 variables, A and B. Can't solve it. Okay, let's try the last 2. Take a look at these 2 ratios. B and C. Can't solve it. There's 2 variables there. What about the first and the third? I don't know A. I don't know C. Even if I set up these 2 ratios, I can't solve it. So we're stuck. The law of sines will not work right now. So since the law of sines doesn't work, my next step is the law of cosines. So let me, again, write this down for you. We said step 1, if it's a right triangle, use Pythagorean Theorem, special right triangles, or SOHCAHTOA. If it's not a right triangle, not right, first thing you do is law of sines. If that doesn't work, then you do the law of cosines absolutely last. That's where we are right now. We're in this very last case scenario. It's not a right triangle. Can't use the law of sines. We have to move on to the law of cosines. So what did the law of cosines say? It said if I had a squared, this would be equal to b squared plus c squared. So a squared, I had to finish off here with the cosine of a, and I put bc here. So then it would be minus, I'm going to put it right there, 2 times b times c. So it's 2 times these 2 times the cosine of a. So all of this is multiplication, and this is subtraction. Now be careful here when you're solving these. you have to use the order of operations. You can't say b squared plus c squared minus 2bc. No, the bc is attached to the cosine a. This is all multiplication. You have to get this answer, then subtract it from this whole answer right there. So be careful when you're solving these. Matthew, say hi to everybody.
What?
So this right here is little a. Here's angle A, so side A is 5. Here's angle B, so side B we know is 7. And here's angle C, so side C is 3. So I could put these in the formula. So over here I will get 5 squared equals 7 squared plus 3 squared minus 2 times B, which is 7, times C, which is 3, times the cosine of A. So this becomes my variable right here. A is the variable, and that's what I'm solving for. So I end up with 25 equals 49 plus 9 minus, okay, I can multiply these, 2 times 7 times 3. So 2 times 7 times 3, this will be 21 times 2 is 42 cosine times A. So now I'll get 25 equals 58 minus 42 cosine A. So at this point, this is where many of you make a mistake. Remember, it's 42 times the cosine A. I can't do this part. I can't say 58 minus 42. So you have to use the order of operations. The 42 is attached to this cosine A. So what I can do, though, is subtract 58 from each side. So 25 minus 58 is negative 33 equals negative 42 cosine A. And now divide each side by negative 42, and I will get 0.78571 equaling the cosine A. So at this point, to solve for A, you have to do the inverse cosine. So we have the inverse cosine of this answer is what angle A is. Put that in your calculator, and angle A comes out to be 38.2132 degrees. So now we have angle A. So now you have options. You can certainly use the law of cosines again and solve for angle B, solve for angle C. But the law of cosines, you could see, is a lot of work. I could just set this back up into the law of sines, and that's what I want you guys always to do. Once you get one of your angles, go back to the law of sines. So in this case, I have the sine, and I know angle A, which is 38.2132 over 5, and I can either use B or C. It doesn't matter. Let's just use B. Sine of B over 7, and I cross multiply right here. So 7 times the sine of 38.2132 over 5. You could say 5 times this, but then you have to divide it back over, is equal to the sine of B. So let's put this in our calculators. And that will give me 7 times the sine of 38.2132 divided by 5. I'll get 0.86602 equals the sine of B. B, to solve that, I need the inverse sine of this. So B comes out to be inverse sine of that 0.866. That gives me 60 degrees, an even 60 degrees. Well, at this point, I can solve for angle C because I don't need to do anything fancy. I just know that it's 180 minus 60 minus this 38.2132. So angle C comes out to be 180 minus the 60 minus this 38.2132, 81.7868 degrees. So now I have all three angles. So the law of cosines is the longest, the toughest, but that's a situation where you will need to use it. We will do more examples later, but we'll stop there for now. Make sure you look this over again for anything you need help with. And as you guys always tell me, smash that subscribe button, hit that notification, pound the like, and I'll see you next time. Mr. N out.